Okay, I am recording. So once again, anything you say will be recorded. All right. Tell Doug Bright, can you be down here sometime after 8:30 and before 8:40? Question mark. So Michaela's here. Kinsey's here. Rice and Red for the extra points. Well, of course, you guys all get extra points. If I don't know if you remember, it's been a while, but for at least a month now, I think everybody who physically comes to class gets extra credit. A little bit. Midkiff is here. Good morning, Eric and Red. Eric Z Red. Extra credit. Today I'm going to record this from two different angles, or two different microphones. Hopefully one of them works. So just a reminder, you have to be in person to get full credit. I know it's been a while, but I do see two people online, and partial credit is better than no credit. So that's great. I'm glad you guys are at least online as opposed to not here. So make sure you send those keywords to me. Everyone else will be getting the 5 points extra credit because today is the day where you get to give me my feedback and tell me what I can do better and what I can do the same. Anybody who sticks around for that gets the extra credit. All right, let's see. So we have Asbury is here in red. Morning. Hudson here. Hodges in red. Massey is here. Less than 2 minutes. So I've started grading lab reports. I'll probably do that over the weekend. I really hate to do this, but I'll give you some advice as far as grades are concerned. I prefer you just to do what's best for your education, which would be do the lab report. But if you don't have a full 100 points in your independent work, I say go ahead and just focus on that. Go ahead and knock out those 100 points first, because to get the most points you can get on that lab report is 20 points. Right? If you do the whole thing and it's perfect, you get 20 points. To get 20 points in a independent work is just 2 pages of double-spaced writing, right? So I hate to do that, but seriously, if you're worried about your grade and you don't have, and you're at least 20 points away from the full 100, I would say write independent work. Focus on getting to that 100 points in independent work before you worry about your lab report. You get more bang for your buck that way. Again, that hurts me to say because I prefer you to do the lab report. It's better for you as far as education is concerned. Maybe, depending on what you write for that independent work. Anyway, any questions about that? Then, the final is on Monday, online as usual. The only difference is instead of having 50 minutes to finish it, you have an hour and 50 minutes because it's going to be twice as long. Again, if you want to take it at a different time, or if you want to take a paper version, or you want more time to take it, whatever it is that you want, I need to know about it by today. Because if I don't hear from you today, I'm just assuming you're going to be online on Monday taking it as usual. And I know I've heard from one of you and I haven't replied back yet, but I did get your email on Wednesday, so you're good. I think that's it. And again, I know I'm preaching to the choir because you guys are here, you're usually here, but please spread the word. Tell your classmates that the exam is Monday at 8. Someone's going to miss it. It's going to suck when they get the 0. But I really hope they don't. Oh, yeah, and then the last announcement. Again, I've already said this earlier today, but today is Student Evaluation Day, where you get to evaluate me. We only have a little bit left in this chapter, so we should be able to finish hopefully around 8:30, at which point somebody's going to come in and administer this for you guys. Yeah, and like I said, you all get 5 points of independent work just for doing that. Any questions? All right, it's 8:01. Let me make sure I'm not missing anybody. I'm going to call the people I have as absent. And if you're online and I call your name, don't worry about it. Just, like I said, send me those keywords after the lecture and you'll get partial credit. Van Cross, Reed, Hemmings, Bowers, Tudor, Welder, Burdett, Newton, Richardson, Cedric, and David. Anybody I miss? Everybody's accounted for? Okay, let's jump into it. I'm going to finish up this chapter. And this is probably one of the easier parts of the chapter too, so that's the good news. Oh yeah, another thing to remind you. Again, the exam is going to be written about half of the 100 questions are going to come from the first 3 exams. And yesterday, somebody met with me and allowed me to record it. So you can go on Google Classroom and get all the correct answers to every single question on the first 3 exams. You can still meet with me if you want, and I can give you feedback about the questions you missed, and we can talk about why they're wrong, and you can get your 5% boost. But as far as studying for the final is concerned, that's taken care of. I highly recommend you watch that video. I mean, if you don't watch the video and then you fail the exam or do poorly, you can't tell yourself, oh, I'm just not good at test taking, right? Because you didn't do the minimum to prepare. So watch the video. And on that note, the same person I think is wanting to meet today at 9 to cover the last 3 study guides. So you can all come in for that too. We're going to talk about all the questions on the study guides. That way, if you have questions, you can let me know. Anyway, if you don't make it today at 9, at least, again, I highly recommend watching those videos or that video. So you'll have 2 videos to watch to prepare for the final. Highly recommend it. The final is worth 200 points. That's 2 letter grades. So, be prepared. And if you need help over the weekend, let me know. Anyway, let's jump back into this. Talking about human population growth. We're going to talk about the history of it. I've already done this little preview. We already talked about this. Through most of human history, parents have had many children. This made sense because the death rate was also high, right? So the chances of you having a kid and then making it to adulthood, or a lot of times even you surviving through childbirth, was a lot lower than it is now. So in a sense, not quite, but in a sense, we were almost, exaggerating here, but we were almost like a type 3 survivorship, right? We were almost like, all right, let's just have as many offspring as we can because they're not all going to make it, so let's hedge our bets. And not only that, but back in the day, depending on the situation, it was often beneficial to have more children because you can put them in the family. These days, it's kind of the opposite. I've got an 11-year-old. He refuses to work, and we live right down the street from Easy Street. He could, bartend or whatever, but he won't do it. He's a drain for us. It's being recorded. He's going to hear this one day, years from now. Anyway, so yeah, that was the situation, right? For most of human history, we were having a lot of kids, but the population was slowly growing, right? The rate of increase was only slightly higher than 0 because the death rate was also high. And there's a question on the study guide that mentions something about this, and it'll probably be on the exam. So when you're talking about human population growth, for most of the human history, basically it's been a really, really, really slow population growth. Most of human history. And that's what you need to take from this slide as far as the exam is concerned. For most of human history, the human population growth has been very slow. Then we had some changes, right? You don't need to write all these changes down. What you need to know for the exam is that there were changes. right? Things changed, and then the population growth, even though it had been really slow for most of human history, all of a sudden skyrocketed. That's what you need to know for the exam, but let's talk about why it skyrocketed. Because there was economic development in Europe and the United States, probably other places too, but those were the big places that led to the advancements in nutrition, sanitation, and medical care. That actually, before I even finished that portion of it, you can leave it at that for now. So that's what happened, right? We were still having a lot of, birth rates were still high, but now we started figuring out how to survive, right? We started figuring out medicine and started figuring out, hey, maybe we should have toilets and sewage systems that get sewage away from the people, right? Things like that. We figured those out, and all of a sudden the people weren't dying as much as they used to. But again, as this first bullet point says, at first the death rate decreased, right? But the birth rate remained the same, which is another way of saying, hey, now the population is all of a sudden skyrocketing. We're still in this cultural thing of just popping out a bunch of kids because that's what you did, but because you needed to. But now you don't necessarily need to because the death rates have decreased. Because that the rate increased by the beginning of the 1900s. And again, I'm not going to ask you this much details yet. That's when it happened. And then, of course, in the mid-century, improvements in nutrition, sanitation, and healthcare spread to the developing world, so not just parts of Europe and U.S., but also other parts of the world. And that spurred a growth as fast as the pace of birth rates far outstripped the death rate. So basically what I'm saying here in this slide, again, like I said, for the past two slides, what you need to know for the exam is, for most of human history, the population growth has been really slow, and then all of a sudden it got really quick, really fast. Because we started fixing, we started, I don't want to say fixing, improving the death rate, right? People started living longer because of things like sanitation and medical rates and all that. Any questions about that slide? All right. Sorry, I've got two screens on today. I'm going to go ahead and put you guys on mute. So if you're online, I can't hear you anyway, so I'm going to mute it. Because I know I've done this before where I've done a video and I was going back and watching it for the questions and somebody wasn't on mute and it was like, you couldn't even hear what I was saying because they didn't know they were on mute and they were just talking to somebody else. So anyway, let's move forward if there's no questions. Oh yeah, attendance words. Sorry, the first attendance word is death. There we go. So the world population skyrocketed from 2 billion in 1927 to 3 billion 33 years later. I'm not going to ask you those details. The point here, that I'm trying to make is after the entire human history of a slow human population growth, all of a sudden it exploded. Luckily, scientists did become alarmed because obviously, if the population growth is exploding, that's eventually going to be a problem. And what happened was the overall growth rate peaked in 1962. Another thing that I'm not going to ask you, but just something to keep in mind, right? So the growth rate peaked in 1962, according to your book. Obviously, the population didn't peak in 1962. It's been growing tremendously since then, but we're saying the growth rate peaked. So remember what I said on Wednesday when we talked about the difference between population growth and the growth rate. Right, so the growth rate has been going down, and the analogy I used was money, like a bank account. So what I'm saying is we're putting less money into the bank every year, but we're still putting money into the bank. So our balance is still going up and up and up. Does that make sense? So even though I may have put in 1,000 last year or 900 this year, I'm still throwing money into the bank. So the account balance is still going up. That's what's happening here. We're putting less humans into the population every year, but we're still putting humans into the population every year. So it's still improving. It's still increasing. Anyway, any questions about this side? Okay. Here's a little chart to give you some info. What we have here is the world population. What year is this? So this is 2012. This is really old, right? I mean, it wasn't that old when your book was published. Because now it's a lot different. We're in 2023. But anyway, back then, the world population, the birth rate per 1,000, the world average was 19.1. The death rate per 1,000 was 7.9, which gave us a growth rate, worldwide, a growth rate of 1.1. And then the more developed countries like the United States, Canada, you know, Japan, places like that, our growth rate was actually pretty small, right? 0.3. It's still positive, so we're still adding to the population, but very small. And then in less developed countries, it's still relatively high, higher than the world average, higher than ours, 1.3. And the point there is, like you learned in the ecological footprint, there's kind of a similarity here. So basically, the more money a country has, and we're not talking about this right now, but the more money a country has, the bigger its ecological footprint, right? Because it's using more resources. Likewise, generally speaking, the more, I guess, no, I'm sorry, this is kind of the opposite, right? So now, the more money a country has, generally speaking, the lower its population growth rate is. So it kind of flip-flops. And if you take Bio 108, we'll have a little bit more time to talk about that, but for here, we'll just leave it at that. I'll put a big X to this because I'm not going to ask you these specifics. This is a great independent work topic, though, because like I said, this is from 2012. So what is the world population growth rate now on average? What about for more developed countries? And you can look up specific countries if you want. The United States, Zimbabwe, New Zealand, whatever. And then, of course, you can look up some less developed countries and give me those growth rates. Any questions about that side? Okay. Let's talk about age structures, and we already have talked about this, so we're just coming back to it again. Last time we talked about age structures, we were talking about age structure in general, like in biology, not necessarily for humans. And I gave you that example of, we were looking at some birds. And it was like, all right, 0 birds were born, 4 years ago. 0 birds were born 5 years ago. 0 birds were born 10 years ago, or hatched, I should say. And then a bunch of birds were born 7 years ago, whatever. Hopefully you can remember that graph. The point being, we could use age structure and life history back in that example to determine what may have happened to a population. Here, it's kind of the same concept. Of course, now we're just going to apply it to humans. So, as your book says, the age structures help predict the population's future growth. I'm not going to ask you this. There might be a question about that on the exam. I probably won't ask you any questions about age structure on the exam, but I'd like to explain it. So here we go. The next slide I'm going to show you is the estimated and projected age structures in Mexico in 1989, 2012, and 2035. This is what we knew the age structure was in 1989. This is what we knew it was in 2012, and this is where we think it'll be in 2035. Long story short, what you need to know for this, not for the exam, just for your own knowledge, age structures help us predict the future, basically, as far as population is concerned. Obviously, things happen, but this is a pretty good model. This little bar says, all right, so these were kids back in the day, right? So these kids in 1989, this is them in 2012 when they were able to have their own kids. And this was their kids, right? And then we know that then we predict in 2035, they're going to have their own kids. So we can look at this shape and determine, also look at the trends in population growth rate and basically predict what the population is going to be. And that is important outside of biology. And I mentioned this on Wednesday, I think it was, for you non-biology majors, right? So if you're into business, look at this is an age thing, right? So if you're selling toys, if you're trying to decide, am I going to sell toys or am I going to sell Depends and Ensure, right? So back in 1989, you're going to want to sell more toys, right? In 2035, yeah, maybe you want to start marketing towards older people, basically, right? Or if you're a criminal justice major, usually younger people commit different crimes than older people. Overall, I guess I should look that up for my own independent work. I would assume like you get more people, breaking mailboxes when they're 17 and more people committing financial fraud when they're 70. Anyway, any questions about this side? There's nothing on this that's going to be on the exam. Okay. That brings us to something called population momentum, which is basically what I described, but here it is in writing. It's the continued growth that occurs after the high fertility rate is reduced to replacement rate. And it results from girls 0 to 14 years of age reaching childbearing years. So this is the more, as far as the exam is concerned, I'm probably not going to ask anything, but if I did, that's what you need to know. It's the continued growth. It's really good to shorten it for that. It's the continued growth. So yes, even though the population growth rate might be dropping, we still have this continued growth. And I'm going to back up and show you the same picture I just showed you. Right? So, whoops. Come on. Nope, wrong way. So yeah, you can see obviously people were having a lot of kids right here. You can tell that by this shape. That means people were having a lot of kids. And the fact that you have this shape means that they're not having a lot of kids. However, the fact that this is so wide, it's going to stay wide. Even though it's not going to go bigger because we're not having more kids, that's still pretty wide. So there's a lot of people. So as time goes on, we're just basically, this is just showing we're going to have a lot of people. That's basically what it's saying. So even though people are having fewer kids on average, there's just still so many of us that even though we've reduced the population growth rate, it's still a pretty big chunk of people being added every year. That's basically what that's saying. So age structure diagrams indicate social conditions. I've already said this earlier a couple of minutes ago, but now here it is in writing. So an expanding population has increasing needs for schools, employment, infrastructure. So I used the examples of business and criminal justice, but also maybe if you're into politics, right? If you're trying to figure out, what money or what things should your country be spending money on, right? So if you have a lot of old people versus a lot of young people, that's going to determine, do you need more money for schools? Do you need more money for, VA hospitals or things like that? Anyway, any questions about this slide? All right, here's another thing. It's very similar. It's the same years, except we're looking at the United States. So again, 1989, 2012, and the projected 2025. Basically, again, same thing, different country. Anyway, I'm not going to ask you any questions about this either. Any questions for me about this? All right. Let's talk about our ecological footprint. Even though you've already done the lab, this should be pretty quick and easy for you. The U.S. Census Bureau projects the global population of 8 billion. This is great. I love this. So this book was written, I think, in 2016. And they projected a population of 8 billion within 10 years. So by 2026. And we just hit 8 billion. I think it was right before the semester started. We hit 8 billion. So they got it. They kind of nailed it. It was a little bit early, but it was within 10 years. But they also predict that we'll have 9.6 billion by 2050. That's a lot of people, right? So then that begs the question, do we have sufficient resources to sustain 8 or 9 billion people? To do that, at the very least, and your book is only talking about food here, but the world food production must increase to accommodate people expecting to live in coming decades, and also improve the diets of currently malnourished. So this is a bit important thing, right? So not only do we have more people, which means we're going to need more food, amongst so many other things. We're just talking about food right now. But not only that, but we already have people right now who are starving to death. So I like that your book points out, we need to figure out a way to feed this growing population, and also need to figure out a way to feed who we have now. Anyway, so I guess the next attendance word will be toe, like you can see right there. So this will be one of those few times where if you misspell the attendance word, you'll get it wrong, because I'm pointing and telling you it's that kind of toe, not the kind you would have with a truck. Anyway, any questions about this? All right. Your book points out that agricultural lands are already under pressure. I'm going to give you some specifics that I'm not going to ask you on the exam. But overgrazing has turned grassland into desert. That's a bad thing, especially for us, because we need the food, right? So if you have cattle that you eat and get milk from, they are eating, and then they turn someplace into a desert that they no longer have anything to eat, right? So that's not good. Also, we have changes in precipitation that has caused food shortages in some regions. That's very vague. You can look it up for independent work if you want. Where are some areas that are having food shortages because of precipitation changes? And you have to think about that. It's not necessarily just like, oh, it stopped raining. So, and that is probably one of the biggest things. But yes, sometimes it's, oh, it stopped raining as much as it used to. It's too dry to grow stuff. So that's a bad thing. But also in some places you could have too much rain, right? Too much rain can be bad too, especially depending on the crop. Your book also points out that the water usage is up 6 times higher than it used to be in the past 70 years. Again, This is an old textbook, so you can look that up for independent work to see if that's changed. And because so much open space is needed to support the expanding population, other species are expected to become extinct. This is common sense, right? As our species expand, other species are expected to go to extinct. This is one thing I didn't really quite understand when I was younger, especially really younger, like middle school, high school. Because I would think, all right, what's the big deal? Like as humans expand, even just in West Virginia, right? Think about it, like you have some woods, and then you clear 5 acres of those woods and you put up some houses. I'm like, oh, what's the big deal? All those things that used to be living there, other than the trees, they can just up and move, right? Those squirrels can move. Whatever's living there can just move a little bit. It's only 5 acres. But as you learned in chapter 20, right, the ecosystem is precariously balanced, right? It's right where it needs to be. It's already at carrying capacity. So once you remove all that habitat and then you push whatever's living out there into the other woods, then you're now above carrying capacity. So yeah, they can go somewhere, but most of them are going to die, right? The population will spike in that other area. The population density will spike, but then it's going to drop back down to where it naturally should be because of carrying capacity. So again, that's something I didn't get, but I get now, right? So it's not like they can just up and move. Even if they can just up and move, there still is going to be that struggle for survival, and most, they're not going to make it. Nature's going to take care of things. And in this case, that would be bad. Anyway, any questions about this slide? All right. This brings us to what your ecological footprint is, and you need to know that for the exam, and I'm sure you already do because you did that lab. The ecological footprint is the estimated area of land and water and sort of air when you think about it. Anyway, required to provide the resources of an individual or a nation consumes, including food, fuel, and housing, the ability to absorb waste, carbon emissions are a major component of the ability to absorb waste. So basically just the amount of space we need to live. And I think what most people get confused of, at least at first, when they think about the ecological footprint, is they think about literally how much space do they take up. Well, I don't get it. I only have a small house on a small yard. I don't take up that much room, but it's not just that, right? So think about the electricity you use. However much electricity you use, at least here, right? We needed to mine the coal to do that. We had to have the space to have the coal mining plant. We have to have the trains to run the coal, and the train tracks that have just, ruined changed the habitats. All that stuff. Your landfill, all the water you need, the food you eat. Anyway, so that's what the ecological footprint is. Does anybody have a question about what the ecological footprint is? All right, so comparing our demand for resources with Earth's capacity, which is also known as biocapacity, which is another word you have been introduced to and you need to know for the exam, gives a broad view of the sustainability of human activities. And this slide right here is basically what you did on the exam. This is all what you were trying to figure out. You figured out your ecological footprint. You knew the ecological footprint of the world, the ecological footprint of the United States. So you were able to compare your ecological footprint to the average human citizen, or the average citizen of Earth, the average citizen of the United States. You could make some comparisons. And then you had to do this, right? You figured out how much you use versus how much is produced. And remember, if your number was negative, and if I remember correctly, everybody had a negative number. That means you were using when your ecological footprint is larger than your biocapacity, and you have that negative number. That means you're using more that's being produced, and that is just not sustainable. And I'll say it again. I said it Wednesday, and I said it on Monday. It is a matter of life and death, not like in the scare tactic way, like we're all going to die next year if we don't fix ourselves. It's not that impending. But yes, we're using more than we're creating, and that just eventually will not work. To put it back to money terms, that's like saying, we're depositing, even if it's a small amount, right? Even if we're depositing $1 million a year into our bank account, but we're spending $1,000,001 a year. It's not quite that big of a ratio, but even then, right? Eventually, you're going to run out of money because you're spending more than you're taking in. Same here. We're using more resources than the Earth can produce. Therefore, we're eventually going to run out. The next word for attendance will be this one that I'm going to circle, and I'm not going to say it. So if you're being calm and watching this or listening to this, briefly open your eyes and read the screen. The circled word, that is the next word. All right, any questions about this slide? All right, according to the World Wildlife Fund, the average ecological footprint for the world population back when this was made was about 1.5 times the planet's biocapacity per person, which again, sorry, this is the person who's going to come in and do the student evaluations. Anyway, that means, again, 1.5, right? So we're using over half of what's being produced, basically, right? So we don't have enough, we're not making enough to permanently sustain us, right? Because we're using more than we are creating. So Earth overshooting the biocapacity is equivalent to depleting our resources, right? So it's not a good thing. And again, I keep saying this, it is eventually a matter of life and death because it's just not sustainable. So again, and this is something you basically could have done for that lab, right? Because you were looking at the different biocapacities, different ecological footprints. But this shows you where it is, right? So here's the world average. Here's the Earth biocapacity back when this book was made. And here's another bad thing that either your book didn't point it out or I didn't include it on the PowerPoint. But another thing to think about is as the population increases, not only is that happening, right? So we're just using more resources as a whole because there's just more of us, but also our ecological footprints are increasing individually because as a world, we're also becoming more affluent. So we're just using more resources individually, not just the fact that there's more of us, but each individual is using more. And then on top of that, as our population grows, Earth's biocapacity is also decreasing, right? Because as we grow, we're destroying, habitats and land. So it's just a really bad situation. Our ecological footprints are creeping up and the biocapacity is creeping down. So it's just getting worse and worse. Anyway, this is just an example. I'm not going to ask you any questions about this on the exam. As usual, if I did, I would give you this picture and ask you a question about it. So you'd have to decipher it. So I could say, like, which one of these countries is below the Earth's biocapacity? India, United States, or Mexico? And you could look, and it is United States. No, that's above it. Mexico, oh, that's above it. India, that's the correct answer. So again, I guess using this as an example, these are the only 3 countries used in this example that are living sustainably. And I don't know if you know much about them, but there's, especially in India, for example, there's a lot of people in India. They're not all poor, but a lot of them are what we would consider poor, right? They don't have the resources we have. Same with Haiti, same with Afghanistan. So I guess what I'm trying to say, and I don't know if what your book is trying to say there, is sometimes, sadly, to live below Earth's biocapacity is usually not a walk in the park. It's not a picnic. Bringing me to this is kind of what I'm getting at. Affluent nations consume a disproportionate amount of resources, meaning countries that have money using more resources. And you learned that in that little video you watched for the pre-lab of the ecological footprint, right? Basically, generally speaking, the more money a country has, the more resources they're using. Which is important because it's not just an overpopulation problem, right? It's also consumption. So it's not just the number of humans on Earth, but also how much we're using. And again, these numbers are old. I'm not going to ask you about them on the exam, but they are great independent work topics because, again, this book was published in 2019. So look this up. Are these numbers still accurate? Are these numbers still accurate? You can look that up. Anyway, another thing you can do for independent work, I'm not even going to tell you what it is. Hudson might remember because he's had Bio 108. But you could look up the IPAT equation. IPAT. What in the world is the IPAT equation? Look it up for independent work if you want. Any questions about that? All right, and then your book shows this picture. Here's a typical kitchen scene in the United States, I believe it was. And then here's a typical kitchen scene in Afghanistan. So you can see, again, your book is pointing out affluent nations were using more resources, generally speaking, than less affluent nations. Any questions about that? All right, then the last word for attendance for the semester is going to be cheese grater, or just grater. We'll just do grater, or grate, whatever. Great or grater, I don't care. That's it. So I'm done. Mr. Doug Bright here is going to tell you what you need to do these student evaluations. And I will be checking my phone and my computer often this weekend since we have the exams on Monday. So if you need me, I'm going to do my best to be there for you.